Thanks, Betty. And thank you all for joining us. As Betty mentioned, my name's Rick, and I'm going to walk through network encryption with Gloo. So the purpose of this webinar is to really do a deep dive on all of the different ways that you might use Gloo while utilizing network encryption. And obviously, stepping back, most applications that you're exposing to the outside world, you need to be thinking about this from a security perspective. And so, we're going to go through all the different scenarios that you might want depending on your environment, depending on whether you're using HTTP features and so forth. And so in this webinar, we're going to kind of look at different scenarios, first with L7 or HTTP routing, different ways that we might utilize TLS encryption with Gloo. And then in the second part, we'll look at Gloo as kind of a TCP proxy and how we can apply the same concepts there. Now, this webinar is kind of going to assume at least a basic knowledge of Gloo. If you're new to Gloo, Gloo is an API gateway. Basically, it's a set of components that manage one or more replicas of Envoy, a proxy, which is an open source proxy implementation. And basically what it's doing is it's configuring different routes on that proxy between end users and your application. So end users can send traffic to Envoy. Envoy can forward that to the right destination. Now, for the purpose of this webinar, we're going to be talking specifically about how network traffic is encrypted between end users and Envoy, and then also how encryption works between Envoy and the services. Separately, there's also kind of encryption concerns or just a question of how does Gloo, the control plane, communicate with Envoy, the proxy. That also we can do through mutual TLS, but that's not going to be the focus of this webinar. And if you find that the content here is going a little bit too deep, we did just upload a video yesterday that kind of goes through a basic overview of Gloo. So if you're struggling to keep up with some of the concepts like upstreams and virtual services, would recommend that you go back and check that out and then look at this video again. Before we get into it, just a shout out to a bunch of customers that we have. These are from our website. You can go to the website and read more about the case studies, what they're actually doing with Gloo. But as you can see, we're working with a number of both small and large organizations, new startups and established companies. Cool, so this is kind of just summarizing some of the different concepts that we're going to talk about. So TLS termination and origination and pass-through. These are basically the different scenarios that I was referring to. We'll go into this in a second. Then we'll also kind of touch on what about mutual TLS and what about connections with a service mesh. Great, and with that, I'm gonna jump right into a demo. So I mentioned this, or Betty mentioned this at the top, but the notes for this are in a repo called Gloo Ref Arch. So if you do wanna follow along, I pasted the link in the chat, you're welcome to follow along, and we'll send this out a bit later. The first thing I'm going to do is install Gloo. I've gone and kind of cleared my cluster here, so this should just take a moment. While that's going, we're going to kind of give some basic setup. So since we're dealing with SSL, I've gone and kind of simulated having a primary key infrastructure or having a public key infrastructure. So, basically I've gone and generated root certificates locally. And from there, I've generated certificates for the first domain that we'll be using. So we're using a service that, a simple Go service that we wrote called Spelunker. We're just going to use the domain spelunker.com for all of the traffic. So this is to simulate a user's navigating to spelunker.com. And so, I've done this, I've gone ahead and done this so that I don't mess it up here in this demo, but basically we just created some really basic certificates for that domain. We can see Gloo's installed, so let me just make sure that it's running. And it looks like it is, everything's running, all good. So next, excuse me. Next, I'm going to install our Spelunker application. Actually, let me see if it's already there. It looks like it is. Let me just make sure I don't have any. Okay. So just to see what this is, our application is really simple service. All it's going to do is when a request comes in, it's going to respond with some basic information. So it'll respond telling us if the request came in via HTTP or HTTPS. And then it'll also just print out some basic stats about the request. And if we look at the manifest, we can see that when we installed this, we created a namespace. In the namespace, there's a single pod that's running our container. And there are two ports, so the standard HTTP port and the standard HTTPS port. And for the purpose of HTTPS traffic, we've mounted a couple certificates. And we did that with a secret called TLS.spelunker.com. And this is where I'm going to introduce a bit of a naming convention here. Because we're looking at a bunch of different scenarios that are all somewhat similar, I've used just the names here of the resources to try and keep it clear what we're looking at. So here what we're doing is we're mounting a TLS certificate into a volume called certs so that it's accessible to inside of this container. And similarly, the service that we've deployed, the Kubernetes service, also exposes those two ports. And so it's basically, it's opening up networking to those two endpoints inside of that container. I think this secret already exists, but I'm going to just make sure. We're just creating a standard. Oops, I'm in the wrong. So we're just creating a standard Kubernetes certificate. Yeah, it already exists, which means that our container should be running and it should be good. I just want to make sure. Okay, cool. So now we want to expose this application to the outside world using Gloo. And as you probably know, Gloo has two key abstractions that we need to set up in order to create that route. So we need to model the service itself as an upstream, as a destination for traffic. And then second, we need to actually create a route to that destination using a virtual service. So the first thing that we'll do is set up just a plain HTTP route using none of the we won't use the secret, we won't use any SSL to start. Let's just take a look at what that looks like. So first we'll create this upstream that represents our HTTP destination. And here, this is a really vanilla upstream definition. In fact, we might have just utilized Gloo's built-in discovery mechanism to produce this. We're not creating any customizations here, but this is what it would look like. So let's apply this. Next, we need to create an actual virtual service that routes to that destination. So here we're creating a virtual service called http.spelunker.com just to indicate that we want to kind of receive incoming traffic via HTTP. So this is traffic from end users to Envoy. And then we're telling Envoy that for requests that match on spelunker.com as the domain and on any path, forward that request to our HTTP upstream, which we didn't provide any SSL config anywhere here, so we expect it's just going to forward that request as a plain HTTP connection. And we should be able to verify that when we actually create this route, because we should be able to curl the endpoint and we should see that we hit an HTTP endpoint. So let's do that now. Now behind the scenes, Gloo's reading this saw that we created this virtual service, seeing that it's referencing this upstream. It's basically computing a proxy CRD. It's an intermediate representation, and then it's translating that directly into Envoy config. And we should be able to now hit it. It should propagate basically immediately. So we should be able to hit this now. To make it a little easier for our remaining scenarios, I'm going to just set up a variable here in my command line. Basically, I'm running a command here to grab from the Kubernetes service that's called gateway proxy. I want to grab the IP address for the ingress that the load balancer established. This is just another way to get essentially the IP address of the Envoy proxy that's running, that Gloo is managing. And this is in my case here, the cluster is running in GKE. So this is a IP address that Google load balancer just granted us. We can see what that is here. Oops. Cool. And now we're going to run a curl command. And again, we're going to just run this as a setup so that we can see how it compares to the other examples. So we're going to curl spelunker.com with an HTTP request. So we're not initiating an SSL connection here. We're telling curl to resolve this URL to that IP address of the Envoy proxy. And this essentially just bypasses the need for DNS, but it does so in a way that will generalize to cases where we are using SSL as well, which we'll see in a little bit. And if I run that, looks like it's working well. So we're curling the HTTP endpoint. As we saw, we set up a virtual service that received HTTP traffic and forwarded it to just an HTTP endpoint. And that's what we're seeing here. So this is working exactly as we expect. So I did that kind of the long way just so that we can start to see what we need to change in order to start playing around with different scenarios for HTTPS. And the first thing that we're going to do is we're going to create basically an HTTPS connection between curl and the Envoy instance. Envoy is going to terminate SSL. Potentially, it's going to perform routing. It potentially might apply any other features that we enable on that route. And then when it sends the traffic onto the upstream destination, it's going to reinitiate an SSL connection to communicate to the HTTPS port on the container. So we need to set up a few things for that. First, we're going to set up an upstream that represents that TLS or that HTTPS port on the container. And let's take a look at what that looks like. So basically, up through here, it looks exactly the same. We're still routing just to that same service that we were before. Now we're routing to the HTTPS port, and we're providing an SSL config that basically, it's expected that this would contain that TLS secret. And by doing this, we're essentially informing Envoy that when it's communicating to this upstream, it needs to initiate an SSL configuration with this certificate. The second thing that we need to do is we need to create a route so that I can issue a request from curl locally to Envoy, and it knows how to get routed to this upstream. So we'll create a second virtual service for our domain. And this time on the virtual service, so we're making two changes from before. The first is we're routing to a new upstream. In this case, we're routing to an upstream called TLS. That was the one that I just showed. And that's the upstream that contains information so that when Envoy matches here and it decides to forward the request to this upstream, it knows how to initiate that SSL connection. The other difference is we're providing an SSL configuration on the virtual service itself. Here, we're actually referencing the same secret because ultimately it's the same certificate that we're going to use here, but this is telling Envoy that for incoming requests, that this is a route for incoming requests that are HTTPS. And that will basically mean that Gloo will have Envoy bind that to the HTTPS listener, and we'll see in a second what that means. So let's apply this. So now we should be able to issue an HTTPS request, kind of like what we were doing before here with curl, except to the HTTPS port. And we should be able to see that we, basically hit an HTTPS server. Just before we get into that, I'm going to show the proxy CRD. So I mentioned at the top, the proxy is Gloo's intermediate representation. This is kind of exactly what it's going to translate into Envoy configuration. So it shows the listeners or the ports that Envoy is listening on. And by default, it's always listening on an HTTP port, 8080, and HTTPS 8443. And as we can see, we basically have used those two. We've got those two routes bound to the correct listener. And we can see, in the status here that it's been accepted. So we expect that we can already issue this curl request. So my request here is very similar to the one before. Obviously, I'm initiating an HTTPS connection here locally from curl. I'm telling, just like before, I'm telling curl how to resolve that, except this time with the SSL port. And I'm also just providing the root certificate here so that it can kind of avoid that insecure warning. And this works again exactly as we expect. We're now we're sending a request to Envoy's HTTPS port this time. Envoy is decoding that, figuring out where to route it to, and is routing it to the HTTPS endpoint on the container that we opened up. And we know that basically this is the text that's different. We implemented it so that it says that it's hitting that HTTPS port instead of HTTP. Cool. So at this point, we have these two different virtual services, one for kind of plain text HTTP pass-through, and then one for SSL to SSL connections, basically all the way through. Now we're going to flip the scenarios a bit and look at the two other cases. One where we're kind of starting from an insecure HTTP connection, sending that to Envoy, and then Envoy is forwarding that to the SSL endpoint. And then kind of vice versa. Maybe we might be starting the kind of HTTPS connection locally, but Envoy is terminating and then forwarding to the HTTP port. So those are the other two scenarios that we could kind of utilize by changing how we're configuring our upstream and our virtual service. And let's just take a look at what those, how we go about doing that. So to make it a little bit more clear, I've created kind of a second domain here, spelunker2.com, and that's basically just to handle the kind of this inverted case that we're going through. So if we look at what this initial virtual service looks like, so this is our HTTP virtual service. So it's going to be receiving, Envoy is going to receive HTTP connections. But here we're forwarding it to a TLS, to our kind of TLS upstream. So we're expecting that Envoy will be initiating the connection and then communicating with the backend over HTTPS. And we could see that was really all we needed to do here because we already had the upstream and the secret for that upstream created. And so what we see is we're curling the HTTP endpoint for Envoy. So we're initiating an HTTP connection to Envoy, resolving that to the Gloo host. But behind the scenes, because of the route that we set up, we configured that virtual service to talk to our TLS upstream. And so we're hitting that endpoint that indicates that the connection came to the backend as an HTTPS connection. So that's the third scenario. And then the fourth scenario is the opposite of this. Imagine we want to issue a curl request that initiates our SSL connection locally. It terminates at Envoy, and then Envoy to the backend communicate in plain HTTP. And you can probably start to guess how we would go about making this configuration. really there's two places that we need to configure for any of our SSL concerns. One is on the upstream for all the traffic going to the backend, and one is on the virtual service for all the traffic going to Envoy itself. So for this last case, I need to create an HTTPS virtual service. So I need to create a route that tells Envoy the SSL config for that incoming HTTPS connection, but then establishes or then forwards it to a backend that is our plain HTTP. Let's take a look at what that looks like. So here's that route. It's just forwarding it to our old HTTP upstream, but here we're going to provide a TLS secret so that we can, so we're telling Envoy that it will accept, or it will bind this essentially to our SSL port. Now I've gone and created a bug here, so I just want to show what that looks like. You could probably guess what the problem is. I never went and created a second certificate, but we're using a new domain, and so when I've made that request and it's fine, but when I issue the request, I'm getting this error that it's for the wrong domain, and that's good. That means we're kind of actually validating the SSL connection, and it means that we need to go create that certificate. So I've gone and, again, like before, I've created one. I'm going to just go and deploy that to the cluster. Looks like it's already there. If we look at what the fixed version of this looks like, all I'm changing here is I'm referencing the correct secret. So, this is just to point out that we really do need to generate certificates for the specific domain. So let's apply this, and we should make progress. Now, subtly, this is fixed, but we're going to run into a problem. So we'll be able to detect that by running gloo check. And generally, as a side note, would recommend that you use this anytime you're really trying to either develop confidence that your gloo configuration is right, or if you're starting to diagnose what's going wrong. In our case, I ran it and we're seeing this error, and what's happening is we haven't properly configured SNI for Envoy. So we've got multiple domains that we're managing with the same listener, and we need to actually set up SNI configuration properly on those virtual services. So let's just look at that real quick. The SNI configuration is very simple. It's just this additional SNI domains field. And again here, so we'll update both of our virtual services with proper SNI. So now we can rerun gloo check. We should see that our proxy error is no longer being reported, meaning that so the error before told us essentially that Envoy and Gloo were out of sync. So Gloo had updated configuration, but it couldn't translate it in a valid way to Envoy. Now we're seeing that there isn't a problem. And so we should be able to finish our test here and actually see this in action. And as we can see, now we're issuing an HTTPS request to our second domain and telling it how to get resolved, but we're now forwarding that one to our plain text HTTP endpoint. So that's to simulate encrypted traffic between the user and Envoy, but then unencrypted between Envoy and the actual backend. And let's just see all four of these. So if we go back and we run our other Spelunker 2 one, we can see HTTP requests get forwarded to the TLS endpoint. And then, we should still see our old ones working. HTTP to HTTP. And HTTPS. Cool. So all 4 of those are working, and those are the 4 different scenarios that you might want to evaluate for your L7 proxying concerns. Before we move on to L4, there's one last detail that's worth mentioning, which is Gloo is, so far we've basically done mTLS between myself here and Envoy, and that's, I provided the CA cert here in order to not skip that insecure check. But we also need to provide the root cert. We've never provided that root certificate to Envoy itself. So Envoy currently is only doing one-way SSL between Envoy and the actual upstream. And Gloo provides a simple mechanism to actually turn that into an mTLS connection, which is to update the secret and to have the root CA in addition to the actual private key and certificate. So if we look at that, we can quickly go change it to set that up. So first we'll deploy the secret. Here I'm just, typically you would create this. This is one of the intricacies about Gloo secrets, is that there's a slightly different format for some types of secrets. So here, this is something that I created with Gloo CTL. It's got just a nested structure. But inside of this contains our original 2 files as well as our root CA. And the Gloo CTL command to create that is in the notes. So once we have that, then we just need to go and update. And so where we were communicating to the mTLS, to the TLS backend, now we want to just change that to mTLS. And we want to do that in both places, on both of the virtual surfaces where Envoy is configured to communicate with the backend over TLS. Great. And now if we can rerun those 4 curl commands, and this time the main difference is that in the background, Gloo is performing mTLS now from Envoy. Great. So that's it for L7 proxying, and I'll just recap briefly before moving on to L4. And I promise the next section is going to be a lot shorter. But basically what we did is we kind of tried to compare and contrast all the different ways that you might set up essentially your traffic between end users and your actual backend through Gloo. And because Envoy is sitting in the middle, that means we've got choices about whether we want to encrypt the traffic between end users and Envoy, and then again, whether we want to encrypt it between Envoy and the actual backend. And so we kind of looked at all 4 different ways. We basically created all 4 of those as different virtual services so that we could see them all side by side to compare. Cool. And with that, I'm going to shift over to the second demo, which is if we're just using L4 capabilities, meaning we're not really, we don't really have a need to, we're not really using any routing features that we would utilize with HTTP. So we have a lot fewer things to configure. First, I'm going to delete these virtual services. I also have found that I need to restart my gateway pod when I'm switching from an HTTP to a TCP proxy. which may be a bug. So if we look, we shouldn't have a proxy CRD object. Remember that proxy is Glue's intermediate representation. Now we've gone and deleted all of those virtual services, so we have no routes. And we don't really want to create new virtual services, which have domains and paths and potentially features that we really can't utilize with TCP. So there's a different mechanism that we can use to set up TCP proxy. And it's very simple. Basically, we'll use that the other object that Gloo uses to construct that intermediate proxy representation, also known as the gateway CRD. So the gateway CRD is the thing that basically specifies one, what is the port that Envoy is going to listen on? And by default, there's always two gateway CRDs by default, one for HTTP on the default port and one for SSL. So the gateway specifies that listener port. It also specifies whether that listener is a TCP or an HTTP listener. And then it, depending on that configuration, there might be a lot of other things that you want to configure. If this was an HTTP listener, we might want to, specifically pick which routes to bind to this port or do a whole host of other things. But for the purpose of the second demo, we're actually using TCP proxying. So we're changing the gateway definition to just say that it's a TCP proxy, which means that we need to provide it the backend right here. We're not creating virtual services. And so I'll update the HTTP backend. Sorry, I'll update the HTTP gateway CRD to just use our old HTTP backend. And likewise with our TLS listener. And the main difference here, again, is that I need to provide that SSL configuration. So I'm essentially just providing that so that when Envoy is receiving traffic on this port, it knows what to do when it's encrypted. And it's worth mentioning just that I needed to also provide this protocol in order for it to work correctly over curl. So I'm going to apply those two. And I just wanted to make sure. Looks like I might have restarted my pod too soon, so I'm going to go do that again. I think there's an issue when you're changing the SSL configuration in Envoy on a particular, for a particular listener port. There's some issue inside of Gloo that I was running into. So that was just cleared up by a restart. Wouldn't really normally run into this. Typically, these changes to our gateway CRDs, are very deliberate. We don't flip them back and forth. So this looks half correct. I'm seeing the HTTP listener bound to the correct backend, meaning that the first listener port set up correctly. I'm not seeing it on the second, which might mean that I forgot to apply some config. Let's take a look. Oh, yeah, that looks like the problem. I never actually updated the configuration for this, so let me do that. I must have just done the other one twice. Okay, now we can see the second listener has been updated. It's got that protocol that I mentioned. It's forwarding to the TLS backend. It's got the secret, so it knows how to handle incoming connections. So let's try issuing the 2 curl requests again. And we can see that one's working just as we expect. And if we do the second one, we're getting some problem here. Let's see if we. Also run into a couple issues like this when I basically modify the SSL configuration in flight for Envoy and kind of flip it between SSL and back. Have run into some issues and that have sometimes been cleared up by just bouncing that pod. I'll give this one more shot. If it doesn't work, we'll make sure to provide the correct config in the repo. But let me just see. Now it looks like I've done something wrong here. Oh, I see. I think I was trying to do some shortcuts. I think what was going on is I had forgotten to create this gateway object lives in the Gloo system namespace. And we have a security restriction that you can't reference secrets in other namespaces. And so in the previous example, I was only using kind of resources in Spelunker namespace. Now I'm in the Gloo system namespace and it didn't have the secret available. Okay, and there we go. So now, once I provided the secret to Envoy, I was able to handle the incoming request and forward it onto the HTTPS port. So with that, I'm just going to recap and then we can wrap this up and switch over to questions. But basically, in the first part, what we were doing is looking at all the different ways that you might configure encryption for different L7 proxying scenarios, where in the middle, we're having kind of Envoy terminate our SSL connection, potentially applying some different features in Gloo and then forwarding on the request. And in the second example, we looked at some, really some simpler examples where we're not using any L7 capabilities at all. Instead, we're just configuring Gloo as an L4 proxy, and we've shown what that looks like if it's like HTTP all the way through or HTTPS. Great, and with that, I think that's it for the demo. So I'm going to switch back to our presentation. We always like to highlight, we went really deep on a few features here related to encryption and TCP versus HTTP proxying. And these are all available in open source Gloo, but there's a whole host of other features that are worth exploring, many of which we've covered in other webinars. So this slide gives kind of a decent overview of all of that. We also have this on our website. So to get a better sense of the breadth of capabilities that you can utilize Gloo for, I would take a look at this and dig into the docs. And of course, there's tons of resources out there to learn more. So check out our website, check out Gloo has a pretty large docs repo. So if you go to docs solo.io/Gloo/latest, there's a ton of guides and different ways to really dig into this and other features. And if you're interested in trying out enterprise Gloo, feel free to request a trial. With that, I'll turn it over to Betty to kind of moderate questions.
Yeah, so thanks, Rick. First question here is what is SNI? Because I think you just used an acronym there, and not everyone may be familiar with some of the terminology.
Yeah, now I need to remember what it stands for. Basically, what SNI is doing is it's basically hinting what the domain for the incoming encrypted request is. It's a way of supporting some amount of routing without having to basically terminate and reinitiate the SSL configuration. So you can think of it really just as an extra hint. So if you're managing multiple domains and you need to decide which certificates to choose for the purpose of receiving that incoming SSL or HTTPS request, SNI helps with that selection.
Great. Another person here had a question regarding the demos, and if you were using GKE, which I believe most of your demos are on GKE, but is there an ability for them to test things out locally? Do we allow Gloo to be run kind of locally on a machine and not kind of like spinning up a whole cloud cluster?
Yeah, for sure. And, for all of these demos, a good option, if you're new to Kubernetes, is Minikube. It's kind of where we used to start. So Minikube is an installation of Kubernetes that you can run locally in a VM that you have. And it's a full cluster. It just has a slightly different networking model from GKE or EKS or one of the cloud provided Kubernetes clusters. So the main difference is that when we looked at our Gloo installation and we were getting the Gloo hosts, we were basically grabbing this external IP, and this was a load balancer IP that Google provided. So obviously when you're running locally, if you're using Minikube, you're not gonna have that. And Gloo CTL has a command to make it just easy to figure out what to use instead, essentially. So you're welcome to kind of run these examples locally. You just need to kind of know how to grab the correct network address. I will note that more recently, we've kind of been moving from Minikube as a default more over to Kubernetes and Docker or Kind. So there's really great tooling around Docker for running Kubernetes locally. And with a little bit of tweaking to these scenarios, it should all work just fine.
Yeah, actually, I sent that to that person. I sent them the link to our cluster setup, which referenced Minikube instructions, but I don't think we have Kind instructions up there at this point in docs.
Yeah.
Yeah.
And we're always trying to improve that part of our docs, along with everything else. But I do believe that we've got some different kind of installation cluster setup guides. So actually we've written quite a few of them at this point. So I would recommend checking this out. It doesn't cover Kind, it looks like, but it should cover everything else.
And if you would like instructions on those, Gloo is open source, and you can go to you can just file an issue requesting, will it work on this or that? And it's something that we can add to our docs backlog.
Yep.
And Rick, one more thing that I think would be nice to comment on is, you talked about network encryption with Gloo from an Ingress perspective. Now, we do know that we integrate with, the Gloo as a gateway integrates with service mesh. Can you comment on how we can also enable encryption between the Ingress to mesh?
Yeah, absolutely. So if we're kind of extending the scenario that we had, one of the advantages of having a service mesh is that we could simplify how we deploy our Splunker service. So you could imagine, sorry, let me pull that up again. You could imagine having a single kind of backend deployment running in Kubernetes that only has our HTTP port, and we're not doing anything related to TLS in this container at all. And the service mesh could have a sidecar running next to this in the same pod. The sidecar configuration could have been provided by an injector. So, as a human writing out this application, I don't have to worry about all the SSL stuff. And that's one of the nice benefits of using a service mesh like Linkerd or Istio. You get really easy kind of mutual TLS out of the box. Now, if you want to connect Gloo to a service mesh, you can utilize Gloo or the Envoy that Gloo's managing as your ingress. So that could be the entry point to your cluster. And it, we've got basically simple configuration that you can supply to Gloo so that it knows how to communicate directly with the sidecars for your service mesh. Essentially, in that scenario, Gloo is, if we're talking Istio, Gloo is functioning as Istio's Ingress gateway. So Gloo and a service mesh, are perfectly cohesive components. They work well together. We do get people asking, well, if I've got the service mesh, why do I need Gloo? And it's a fair question, but I would look at just the features that you get, or if you think about kind of what you need at your ingress, Gloo, the use case for kind of your north-south, your ingress traffic is a little bit different than east-west. We found that the ingress capabilities that Gloo provides complement the mesh. And we'd love more feedback on that. So, but there is that nice story. And we often recommend, start with something Envoy based. And if you don't have anything yet, it might make sense to start with the gateway, which could be kind of a stepping stone to running Envoy everywhere and getting a full service mesh up and running.
Awesome. Let me check here to see if there's any more questions. Looks like we are good. Can you just flash that last slide again, Rick?
Yes.
Awesome, folks. So we will have the recording posted online on our YouTube channel by the end of this week, tomorrow. And if you want to learn more about Gloo, we've got the links to the product page to download the open source and request an enterprise trial. I will update the link to that demo to point to the reference architecture that Rick showed during the tutorial today. And if you have questions later on, please feel free to hop into slack.solo.io. It's our Slack community, and we have a channel for both Gloo open source and Gloo enterprise, and our engineers are in there, as well as other folks from the community to help answer any range of questions on configuration and use cases. So with that, thanks, Rick, for presenting, and thanks everyone for joining. We will see you next time.
Thank you.
Bye.